Hi, I'm Loe Chuan. This is our operating system assignment. The title is Dynamic Partitioning Placement Algorithms. Our team is set up by 5 members, which are Adele Gosuk Yi, Wee Wen, Go Yu Kun, Loe Chuan, and Chu Pei An. This is our first question for this assignment. So for step 1, we draw a table. This is the table. And we combine the table. We combine the whole inside the table. We combine whole together, and we calculate the space of the whole. So this is our process number and the size in kilobytes for those process. So we start our first fit. The table got 5 holes. The first hole is containing 25 kilobytes of space. The second one is 30. The third one is 60. The fourth one is 36, and the fifth one is 94. So we start our process number 1. The size in kilobyte for process number 1 is 60. So when it comes into the first hole, which contain only 25 kilobyte of space, it cannot fit into it. So it proceeds to the second hole, which contains 30 kilobyte of space. So it again cannot fit for process number 1. So we go into the third hole, which is 60 kilobyte of space, and this time it can fit the process number 1. So we put our process number 1 inside the third hole, and this process is full for the third hole. So the second process number is number 2, and the size for process number 2 is 18 kilobyte. So it comes into the first hole, which got 25 kilobyte. It can fit the second process, so we put the second process at the first hole. So 15 plus the 18 kilobyte is 33. So we stop at 33, and we cut it off by the hole, which is 40. So we use 40 to minus 33. The hole is left 7 kilobyte of space. So we go into the process number 3, which the size in kilobyte is 20. So when it comes into the first hole, this time the first hole is left up only 7 kilobyte, so it cannot fit it. So it go into the second hole, which contains 30 kilobyte, and this time the second hole can fit the third process. So we put our third process into the second hole, and the hole is start from 70 kilobyte until 100. So we add up the third process, which is 20. So process number 3 start at 70 and stop at 90. So we use the hole to cut off the kilobyte for the process number 3, which is 100 minus 90. We left out 10. So this hole is containing 10 kilobyte. So we move on to the process number 4, which the size in kilobyte is 36. So this time when we start on the first hole with 7 and the second hole with 10, two of them cannot fit the fourth process, and we go to the fourth process as the third process is already been filled up by process number 1. So we straight away go to process number 4 with 36. 36 is fit to process number 4, which is also 36 kilobyte in the size. So process number 4 fill up the fourth hole. So we proceed to the fifth process with 7. So we enter to the first hole. The first hole, just now we mentioned it is left 7 kilobyte. So which match to the fifth process. So we put the fifth process to the first hole after the process 2. Next is the best fit. Say we start from process number 1, which contains 60 kilobyte, and for best fit we have to find the smallest hole to match for the process number 1, 2, 3, 4 and 5. So we start from process number 1 with 60. So the first one, we go into the first hole, which is 25 kilobyte. It cannot fit. We go into the second one, it also cannot fit. So we search for the third one, this time is 60 kilobyte, which can fit for the process number 1, but we go on to search for the next and the final one. The fourth one is 36 kilobyte, cannot fit, and the last one is 94 kilobyte, which is too much, and we wanted to find for the smallest one. So the third one is the most suitable, so we place it at the third hole. So we go on for the process number 2, which is 18 kilobyte. This time we go into the first one and take a look, 25, and go on 30, and go on 60, go on 36 and 94. The whole all can fit for the process number 2, but we have to choose the smallest one, so which is 25 kilobyte. So we place our process 2 in the first hole. So we start at 15 and we stop at 33. And we cut off from the hole is 40, cut off the 33 is 7. So 7 left up in the hole. So we go on to the process number 3. This time the process number 3 is 20 kilobyte. And we search for the first hole. The first hole this time got only 7 kilobyte, and the second one is 30 kilobyte, and the third one is 36 kilobyte, and the last one is 94 kilobyte. we have to pick the smallest one, which is 30 kilobyte. So we place our process 3 into the second hole, and the second hole is start from 70, and we add up the size in kilobyte for process number 3 is 20, so it stopped at 90 kilobyte, and we use the hole to cut off the stop one. With 100 cut 90 kilobyte, we left 10 inside our hole. So we proceed to number 4. The size in kilobyte is 36. So this time we search from the first one. It's just left 7, and the second one is just left 10, and the third one is 36 kilobyte. This time we can place our fourth process into the third hole, which at here start from 254 kilobyte and end up in 290 kilobyte. So we go on to process number 5. Process number 5, the size in kilobyte is only 7, and we go to the first hole. The first hole is just left 7 kilobyte, so it is matched for the 5th process. So we place our 5th process in the first hole after the process 2. So we end our best fit part. For the worst fit part, we have to pick the largest hole and place our process inside the largest hole. So we start from the process number 1, which the size in kilobyte is 60. So it go into the first one 25, second one 30, third one 60, fourth one 36, and fifth one 94. So we have to pick the fifth one. It is the largest one, and we'll place the process number 1 inside the last hole, which start from 380 kilobyte, and we add the process number 1 into it, and it end up at 440 kilobyte. So for this hole, it is just left for 34 kilobyte in it. So we start our process number 2, our second process. The size in kilobyte is 18. So we start at the first one 25 kilobyte, second 30 kilobyte, third 60 kilobyte, fourth 36 kilobyte, and the last one which left 34 kilobyte. So this time we have to pick the largest one, which is 60 kilobyte, third hole. So we place our process number 2 into the third hole. We start from 140. We add up the size in kilobyte for process number 2 into it, and it ends at 158 kilobyte. Next, we start our process number 3. Our third process is contain 20 kilobyte on it. So from the first one, 25 kilobyte, 30 kilobyte, and after cutting off for just now, we just we left 42 kilobyte for the third hole, and the fourth one 36, and the last one after cutting off for the process one, we still left 34 kilobyte on it. So the third process is fit to the largest one, which is 42 kilobyte on the third hole. So we place our process 3 after the process 2 in the third hole. We start from 158 and end at 178, and we continue the process 4, which the kilobyte in it is 36. So we start again from the first one, 25, 30, and after cut off by the process number 3, just left 22 kilobyte at third hole, and fourth hole 36, and the last hole 34. So this time we place our process number 4 at the fourth hole, which is 36 kilobyte, the largest hole that left for now. So we place it at the fourth hole, which start from 254 kilobyte until 290 kilobyte. After that, we start our last process for the process 5. The process number 5 contains 7 kilobyte in it. So we start from the first one, 25 kilobyte, 30 kilobyte, 22 kilobyte, and the last one is 34 kilobyte. So the last one contains the largest hole in the table. So we have placed the process number 5 inside the last hole. We place it after process 1, which start from 440 kilobyte until 447 kilobyte, and the worst fit for the table is done.
Question number 2. So we start with the 3 steps. First, we draw a table. Second, combine the hash. Third, calculate the space of hash. So we start with draw a table, and then copy down the U and hash. And then, as you can see in the question, we have 2 hash that stick together, so we will combine it into 1 hash. And then we start calculate the space of hash. The first hash, we use 10 minus 0 equals to 10. So we need to calculate the rest of the hash by using the same formula. Now we do the first fit. First we draw tables. Second we copy down the U and hash. And then leave some space in front of the hash to easy put in the process number. Now we start with the process 1. We check the hash from front to back. So now we check for the first hash. Is it enough for process 1 to put in? No. So we will check to the next hash. The next hash has 50 size kilobyte. Is it enough for process 1? If yes, then we will use the hash 2 minus 14 equals to 36. So this hash is updated to 36. Next, we'll do the process 2. And then we check again from front to back. If the first is not enough, then we will check to the next hash. Next hash is 36. It is enough for process 2. So we'll use the 36 to minus 35 equals to 1. So we will do the same things to the rest of the process number. So we will write down the remaining hash. Next is best fit. So we start with the tables. We copy down the tables and the U and hash. Leave some space in front of the hash. And then we can start with the process number. The best fit is different with the first fit. Best fit is we need to check from the smallest to the biggest. Check the hash and the process number. The process number is fit enough with the smallest hash? If not enough, then we go to the second smallest hash. Process 1. Process 1 is fit in the smallest hash? If not, then we go to the second smallest. The second smallest is 50. 50 is enough for process number 1. So we use the 50 minus 14 equals to 36. So remember, the second smallest hash is updated to 36. Next, we'll do the process 2. So we check again from the smallest to the biggest. Process 2, is it enough and fit into 10? If not, then we check to the second smallest is 36. Is it enough? If yes, then we will use the second smallest to minus process 2. So we will do the same step to the process 3, 4, and 5. The remaining hash is need to write down. The last one is worst fit. Worst fit is different with the first fit and the best fit. Worst fit is start from the biggest space of the hash to the smallest. So we draw the table first and then copy down the U and hash. Leave some space in front of the hash. So we start with the process 1. We check the space of the hash, which one is biggest. Then we fit the process 1 into the biggest hash. Process 2. We check again from the biggest space of hash to the smallest. So we use the biggest one is 110.2 minus process 2 equals to 35. Next is process 3. Process 3, we use the biggest hash, which is 108, the updated hash, to minus process 3. So 108 minus 20 equals to 88. So we continue to do the process 4 and 5 with the same state.